hope so. Won't have any lag here. I've taken the problem from this one, distinct subsequences. So yeah, um, so we are given two strings s and t. Return the number of distinct subsequences of s which equals t. So a string subsequence is a new string. I've not solved it, right? Take that. A string subsequence is a new string formed from the original array, blah blah blah, and then AC is the subsequence of ABCD, but AEC is not because AEC will violate the property of a subsequence. Okay, I will check if I have shared this thing. Okay, done. Now the test cases are generated so that the answer fits on a 32-bit signed integer, right? Okay. S is a rabbit, so it's RA triple BIT, and then T is a rabbit. So I think so I need to find that how many times is T appearing in S in the form of a subsequence. So subsequence, right? Distinct subsequences, okay. In this case, the output is 3 because we have this thing RA. This triple B could be paired up with this double B 3 times. 3C2 is how much? That's 3 factorial, which is 6 by 2 will be 1. 6 by 2 will be 3. Yeah, 3. So answer is 3. Okay. So is there any factorial involvement here, or I mean, I know right now that this is a dynamic programming problem, so I will definitely go ahead with that. So bad to bad. So bad can be like, let's say this BA and then this G, correct? Yes. And then this BA and then this G, that's 2. Then let's say this B, this A and this G, that's 3 answers. This B is 4 answers, B A G, that's 5 answers. That's why. Yeah, all the possible things. It's 1000, okay. Back, go back. Okay. So this thing is on, right? Okay. So what I could have here is, let's say I have something like A, B, C, D, and let's say here I have A, B, C. So let's say this is the string S and this is the string T. And here I'll say that, okay, let's keep a pointer. So let's say there's one pointer here and there's one pointer here. Now, if these two things are not matching, then this pointer will stay here itself. This won't move, but this pointer will shift and move to C. Now again, I match this and this. That's one added to my answer. Yes. What else can we think of? Let's say this was A, B, C, C, and then A, B, C. So I know this. The answer to this will be 2 because I can pick this A, B, C, and then this A, B, C, A, B, C, and then this A, B, C. This. So probably I'll write it in this way: A, B, C, and then I can pick A, B, and then C. So that's A, B, C. So again, this is, let's say S, and let's say this is T. I'll keep 2 pointers. So I think so. If they don't match, I'll go back. But even if they match, I will go back. Is that making sense? Because let's say if they match, huh, if they match, then I go back here as well and here as well. And I can also try one more thing, that if it's, even if it's matching, keep this pointer here and just move this back here, and then this will form the other answer. So the pattern would be like this: key A, B, C, C, and then A, B, C. So the matching would be firstly this, and this. I'll use different colors. This, and then the next one, the matching will be this, and this. That's it. That's 2, which is the answer. I hope so. Okay. Am I lagging or something? Because my whiteboard is lagging. Okay, so let's say I can probably write here. My result is going to be a function, or it's going to be giving me the distinct count, right? So I'll say count distinct, and then I'll take in the index here, which is initially 0. And I'll maybe start from the very end, so that will be length of s minus 1, and then for the t value, that would be length of t minus 1, and then I guess I'll have to pass s and t. End of the day, I have to return back the value, which is result. So let's say this is my function count this string, if I'm not wrong with the spelling. We have two indexes, right? So let's say the index to x is idx s, and the index to t is idx t. Then we have s and t, right? So s is nothing but I guess the source, which is given to me, source string, and this is the target string to be formed. So it's better to name it like this. I know that one of the base cases here could be that, let's say I keep on comparing, and in this target string, turns out that after accessing this index, let's say after accessing this index, I go out of bound, which is I am at the -1th index. I know I've matched every single character, every single character in target. Hence, I can give a return value as 1, because this means, yes, this is one possible answer. Else, 0 will be something which I will be interested in. When this goes out of bound, but this is still left. So probably some situation like this. This is some source string, this is some target string, and let's say in source string my index goes out of bound, but in target string my index is still there, still somewhere in the middle, which means I never got to compare this in this. So that's an answer 0. Else, if here I go out of bound, that's an answer 1. So one of the base cases would be that if idx of t is less than 0, in that case, I think so I can return 1, which denotes what do I say? Denotes it's a match. It's a match. I did started the stream, right? Yes. Denotes it's a match. And but let's say one of the base cases could be that if idx of s is less than 0, this means that I was not able to match. So this says denotes that it is not a match. Not a match indeed. Yes. Okay. So these are the base cases handled. So this is end of base case. Now let's say I have two possibilities here, that if the current characters in the source and target are the same, then match them. But the other option is don't match them, right? So if I match them, that would be what? If I match these two values, that would be when will this match them come? So match them will be initialized with 0, by the way. So if source of idx of s is equivalent to target of, I guess, idx of t, this means that, okay, both of the characters in source and target are similar. In that case, I'll say match them will be a solve function call. I think so. No, it's not named as solve, it's count distinct. So this will be nothing but count distinct. I have to count the distinct number of ways. Count distinct, and then I think so I have to provide in idx of s minus 1 because I'm going one step backwards, idx of t minus 1 because I'm going one step backward in target as well. S and T will be followed. So in this case, S and T is nothing but source and target, if I'm not mistaken. Yes. Let's count distinct, if I'm not wrong with the spelling. Done. Match them, right? And another one is don't match, which is going to be simply count distinct, count distinct. I guess in X I need to go back, but in T I will be as it is where I was. Source will be still the same and target will be still the same. End of the day, I can say total value, total distinct, what do we say, distinct ways is going to be what if I match them plus what if I don't match them, right? And then I can probably return this total distinct ways. Okay, let's try to run this. This is running fine. Use the example test cases, run this code. Running good. I think so. This should give me a TLE because if it's a TLE, then I'll memorize these two indexes, IDXS and IDXT. Yeah, time limit exceeded. So let's create a hash map DP, and then DP is being passed here. So DP, and then here itself I'll say that after end of base case I'll say that okay, check if the current state, which is denoted by IDXS and IDXT, is already visited or no. So that would be if probably what's my current state? Nothing but IDX of S comma IDX of T. So here itself I'll say that okay, if my current state is in dB, in that case I will return the value of that current state. That's it. And if it's not there, in that case, end of the day I will memorize the current state, which means okay, store the value of the current state. I'll simply say dp of current state would be total distinct ways, and that should be it, I guess. Let's run the code once again, and I'll run it for this as well. Count distinct missing one required position argument dp. Okay, where is it? Okay, I think so. I need to provide this here, and then I have to provide this here as well. I think so. This should be good to go. Submit this. It's still taking a lot of time, but what do we say? How can we speed up the process? So any hint? Only data topics, dynamic programming. Is there similar questions are also not really that relevant? Mm, okay. Let's do different one then. Distinct subsequence has been done. Kind of wanna do. Mm, maybe this one. Longest increasing. I'll refresh this because it will show me the one which I just did. So distinct subsequence has been solved. I'll see this later on because I attempted this but was not able to solve it, I guess. Yes. Mhm. Okay, longest increasing path in a matrix. अच्छा, given an n m cross n matrix or n cross m जो भी है matrix, return the length of the longest increasing path in the matrix. So what's the definition of longest increasing path? So from each cell you can either move in four directions: left, right, up or down. You may not move diagonally or move outside of the boundary, definitely. So I cannot move diagonally, and diagonally means top left corner, top right corner, bottom right corner, bottom left corner. Or I cannot go out of the matrix because that will be, what do we say? क्या एक्सेप्शन होता है? एरे मैट्रिक्स आउट ऑफ बाउंड एक्सेप्शन बोल सकते हैं, similar to array index out of bound. So from each cell you can either move this wrap around, then longest increasing path. So I think so. The thing here is increasing path means if I am at a value x, then the next value in the path would be x plus 1, x plus 5, x plus 100. So it should be increasing, not decreasing or some random values. In this case, I think so 1, 2, 6 and 9. I have submitted this or no? यहीं से पता चल गया ना, सबमिट नहीं किया, कहाँ गया? I've not submitted this. Okay. So from here onwards, I know key from if I start from 1, I'll go to 2, then 2 to 6. Maybe I could have gone from 6 to 6, but no, that's not allowed because this 6 is not greater than this 6. It should be strictly greater, I guess. Longest increasing path. Okay. Answer is 4 for this. Can I have some other path? 1, 8, 9, 1, 2, 1, 6, 9, 3 होगा आंसर, right? ये भी नहीं है. Okay. Hmm. In this case, it's what if I go 1, 2, then I'm stuck here. 1, 6, 2 is the maximum, but from here I see 3, 4, 5, 6. Answer is again 4. Matrix is 1 then. So by default, answer is 1 because answer is 1 by default, right? Because even one single character is a path, simple path. My voice is getting recorded, yes. Now, okay, this is 200, and then let's try this. How many are submitted though? 400 kills. Good number though. So let's say I start at a particular cell 9. Then from 9, I will see in all the four directions that are these four directions. In any one of these four directions, if I see a number which is greater, I will try to go there. And then from there onwards, I will try my best to find out. From there onwards, I'll try all the other possibilities. But I think so I have to also keep track of something which is a visited set, visited matrix, I guess, because that will give me an idea that, okay, this is the current thing visited or not. So if I go from 9 to 6, let's say I go from 9 to 6. So, no, I cannot go from 9 to 6, by the way, my bad. So let's say I go from 1 to 2, then automatically I cannot go from 2 to 1. So I don't need to keep track of visited. So this is what I was thinking. Ki, let's say there was a value 4 and there was a value 5. So if I'm at 4, I will be able to go to 5. Now when I'm at 5, I was thinking that, okay, there might be a possibility of going to 4. So I have to keep track of a visited set, which will say that, okay, 4 has been visited. But I think so, if I am going from 4 to 5, by default, I won't be able to move to 4 at all. So I don't need to keep track of a visited set. Okay. तो ये भी गया एक चीज. Okay. And then from there onwards I have to try all the possibilities. Okay, so the idea could be like this, that if I'm at a particular cell, go here, go here, go here, go here, from again here try all possibilities, from here try all possibilities, here let's say try all possibilities, and then so on. Now let's say from here onwards I tried here and then somehow I went to this possibility. So I know the answer to this is stored already x, so I'll return back x instead of trying this again. Instead of trying this again, I'll store back x, I guess. Okay, so here I can simply say that my result would be what could be the function name? It could be longest path. I think so that will make sense. Longest increasing path, but that is already there. So I'll just simply name it as longest path. Okay. Longest path. What do I need? I need the positions here, right? What could be the positions? So here the positions could be the cells itself, right? So I can start from any single point, right? So yeah, I can start from any single point. So I can say, let's say my initially result is 0. I mean result is 1, which is my longest path. So for I in range, or for, let's say, this will be better for the viewers to get this. So this, and then for column and range matrix of 0. If matrix of row column not in DP, I guess, or no, let's not firstly assume that it's a DP problem. So let's say result is equivalent to the maximum of whatever the result is, and then what if I call the function longest path here, and then I guess I need to pass in row, column, my matrix, and I think so that should be it. End of the day, I could return the result, which is the longest increasing path. Beautiful. Now here itself, I can simply say, let's have my function longest path, and then my row, column, and the matrix follows. Now here I have to one base case, or probably you can interpret this as an edge case. I think so. There will be no base case here, by the way. There's nothing as such base case. There could be an edge case here, which says that okay, if my row is less than 0, or row is greater than equivalent to the length of matrix, or my column is less than 0, or my column is greater than the length of matrix of 0. In that case, I know it's a edge case, so I'll return 0. So what am I doing here? I'm just simply handling the boundary case. If I make sense here, okay. We have the thing, right? What the code doing? Keep boundary. So here, no solarized light. No, that would be too bad of a thing. Solarized dark. Looks good now. Not at all. GitHub. What is GitHub saying? Okay, let's try this. So I'm saying that okay, simply handling the boundary case, right? Okay, yeah, edge case. Yeah. Now one other thing here I could do is let's just increase this thing. So I'm at a row and column, right? So I have the option to go in all four directions, which is probably up, down, and so on. So I can simply say that okay, my directions is going to be this. So if I'm at x comma y, I can go to the, let's say, upper cell, which will be row -1 and the same column. So I can simply say that could be yeah, row -1 and column will absolutely do fine. Then if I go to the next row, that will be row +1 and then column. I can go to the right side, so that will be the same row but column plus 1, and then I can go to the previous column, that will be the same row but column minus 1. That's it. So these are my directions. So I'll loop here. So for new row, comma new column in directions. So again, I think so this is required, right? So let's have something like define valid, and then this takes in, let's say, a row, column, and then the n and m values, which are probably the number of rows and columns. So I think so I can just simply paste this here. That will help me a lot. And okay, so let's go back here. Let's do that, and then paste this here. Again, I missed it. So copy it and paste this here. Control P, finally. So if that's the case, then I return. I'm checking for invalidity, right? So return true. Else I'm saying that okay, return false. Basics 101. So here I don't need to do all of those things. So simply say that if invalid row column length of matrix, and then this will be length of matrix of 0. If it's invalid, then I simply say that okay, I'll return 0. And this is simply handling the boundary case. So I don't need to write that same thing if row is less than 0 and then blah 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 so on for this new row and new column as well, which I'm going to write right now. So again, I'll check that okay, if invalid, see the same thing, new row, new column, length of matrix, then length of matrix of 0. In that case, I'll say that okay, continue, because I don't need to do any stuff here. I don't need to do any stuff here. But if it's valid, now I know that. Now we know it's valid. But again, we have to check a very small edge case, because we can go from a value x to x plus 1, right? Or a greater value, right? So the case here would be that, let's say, if matrix of new row and probably my new column is greater than matrix of the current value, which is row and column, in that case I know that okay, we can try this possibility. Yeah, and how will I try this? So I could have something like this here, that we have few possibilities. So we have the possibility that okay, we try, and we have the possibility that okay, we don't try. So not try is also 0. So if we try, I think so this will be try is equivalent to one cell from my end, which is matrix of row column, plus one cell from my end, which is matrix of row column. Let's say I go here in this format. Let's say there are some values 5, 5, 5, 4, and let's say this is 3. So I can go from 3 to 4. So I'm adding an answer of 1 plus a function called at 4. But from 4 I see I am blocked here. I can't go anywhere, right? So that implies key. So definitely 1 plus something, because, or if it's invalid, I return a 1. That could be one of those things. No, invalidity means simply return 0, right? If I go here, return back 0. So at 4, I think so I won't be able to return anything, hence I'll return back a max value which is 0. Now this is returned 0, so this is 1 plus 0, which is 1. And a function call at 3 gave me the answer as 1 plus, because that's okay. Yeah, that's why we need 1 plus whatever we got from here. That's 2 is the answer. 3 and 4 is the longest path here. It did. I mean, I can go from 4 to 5, but what if this was 1, 1, 1, right? So I cannot go there. Uh, so here try would be 1 plus function call would look something like this, longest path. And I believe so. This will be new row, a new column, and my matrix itself. If I'm not wrong, these are the parameters. Okay, and so I should switch back to the target mode. Yeah, Eclipse also looks really good. We have TextMate. Okay, what is this? Not relevant to me. Xcode. Oh, this is more appealing to the eye. Hmm. So, monocolor. This is the classic one. So, if I try, then this is what it would look like. By the way, try is like problematic thing, right? So I can say try and not try. So this could be, let's say, try. This is a very bad way of naming the variables. So pardon on that. So if matrix of new row is greater than that, then I go there and try. Else I say that okay, we don't try, right? So if I'm at here, I go there or I don't go there and try other. Uh, 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 hmm. So let's say max value is 0 initially, and then I don't think so there will be a condition of not try. So in try itself I will update here. So max value will be maximum of max value, and then whatever the heck my try is. Done. End of the day I think so I need to return max value. I think so I'm missing out on some point because directions. So if that's greater, then I know we can try this possibility. Then try is this. Else by default we are not even trying the possibility, right? Let's try our luck on this. Let's run this. Matrix is not defined. Okay, great. Where is it? Uh, Longest path row column matrix, right? Acha, so there's nothing as such a. So this will be n, my bad, and this will be m. That's the number of columns. Okay, that's really my bad. List index out of range. Definitely. This is bound to come. So इसमें भी क्या हो रहा है कि length of matrix I passed in, length of matrix of 0 also I passed in. Go to the next previous cell, next column, previous column. That's my directions. So new row, new column. Okay. So if matrix of new row, new column. So if it's invalid, then I'm saying continue, right? तो क्या problem आ रहा है इसमें? If it's invalid, then continue. Continue will get the statement down to here, and then I'm left with no possibility. Key can't do any stuff here. Column is greater than equal to 1. Okay. Cool. My output is 10. They expected it as 4. Okay. Hmm. So I'm going from row column to this new row new column. So if that's greater, then I go there. String 1 plus this value. I think so at 9 9 4 में क्या हो जाएगा 8 आ जाएगा, right? And then I'm saying result is my bad. So result is max of result and 1 plus of this. Okay, then run code. क्या कर रहे हैं? 4 is the answer. Use example test cases, run code. Sure. Yeah, and I think so again if I submit this, this will give me a TLE because I have not saved the previously visited states. So just giving me some answer here. I don't know. TLE as expected. So that's the DP thing again, and then here as well I'll pass in DP. I believe so. Here instead of even declaring this, I'll say that okay. Let's check if the current cell is already visited. And what's my current cell? That's pretty much, I guess, row and column. And then here itself I'll say that okay, if current cell in dp, then return that value. So that will be dp of current cell, correct? Dp of current cell, and that's it. Like I'm using the power of dp here. Else if it's not there, then here itself I'll say that okay, let's minimize the value. So I can simply say dp of current cell would be max value, and end of the day I'll return that. So again, let's run the code. Takes in 3 positioned arguments, but 4 were given. Definitely, I am start. Okay, I forgot to put in DP here. I have to put in, where is it? Where is it? DP here as well. Done. Run the code. Should be good to go. Yeah, I'll submit this. Hmm. We have follow-up problem, number of increasing paths. So over there it was the longest increasing path, but here it's number of increasing paths in it. So this is the number strictly increasing paths in it such that you can start from any cell and add at any cell. Since the answer may be very large, run it modulo run the cell. Two paths are considered different if they do not have exactly the same sequence of visited cells. Here it will be 1, 2. So 1, 2, 3, 4. 4 should be the answer. Okay, answer is 8. 5. Increasing paths with okay, so all of them count as paths, right? So that's 1, 2, 3, 4, then 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 is the answer. इसमें सेम चीज रहेगा राइट की for that state I'm storing the number of that thing, the number of longest increasing paths I'm storing. So instead of doing a max, I will simply add the value. So what's the number of increasing paths from 3 onwards. That could be some value. Kind of similar to what we have done. Similar question on path. This has been done. Okay, let's just quickly do this then. Result would be initially, I guess, let's say 0. So for row in range length of grid or column in range length of grid of 0. In this case, I'll say that, okay, result is going to be the maximum of my previous result and a function called to compute the thing, right? So let's say compute, and then compute function is going to take in row, column, and the grid itself. I hope so that's correct. End of the day, I have to return the result value. So let's have the compute function here, which takes in row, column, and then grid. Even before that, again, let's do that ritual of defining this thing invalid row, column, and then it will take in n and then right. That's it. So what's the thing that okay, row is less than 0, or my row is greater than equivalent to n, or my column is less than 0, or my column is greater than equivalent to n. In that case, I return true because it's invalid, else I return false, which kind of denotes that the current cell is valid. Beautiful. Here the base case, or probably I have to do the edge case, right? Yeah, the edge case is to simply check if it's inside the boundary or not. So if invalid, if the current thing is invalid, correct, in that case I can probably say if it's invalid, then I return back a value which is 0, which kind of makes sense, denotes that this is not the pathway. Kind of makes sense. Then I'll have directions. So again, in directions we'll have few of these possible directions. I guess 4 directions, right? So previous row would be what? Row minus 1 and that same column. Then I can move to the next row, that will be row plus 1 and the same column. I can move to the previous column, that will be same row but column minus 1, and then I can move to the next column, that will be row but simply column plus 1. Done. So let's simply loop here. That would look something like this. For new row from a new column in directions, I think so that's much faster than using a for loop or something like that. Again, I'll check here that okay, if invalid, yeah, if it's invalid, then in that case there's no way to go, no way to hide. So invalid new row, new column, and I think so I need to pass in length of grid, I believe so, and length of grid of 0. If that's the case, then simply continue because we don't have any way out of this. Okay, but if it's not there, then I know that okay, this might be valid. And how do I check that? If my grid of probably new row, then new column is greater than grid of probably my current cell, which is this thing. In that case, I know that okay, this is valid. My bad, this is valid. So what do we do here? I'll say that okay, for this one, the number of ways, not ways, right, number of increasing paths. So I can simply say count paths is initially 0. Yeah, that's absolutely true. Count paths is initially 0. By the way, count paths would be initially 1, right? Because I'm considering that cell itself as one of those things. Yes. And then I think so here itself I can say that I need to say count paths plus equivalent to 1 plus compute function will be called again with the new row value, the new column value along with the grid, and end of the day I need to return the count paths for this cell, right? Let's see. Output is 5, the expected 8. Where are we going wrong? Okay, so I think so. Okay, so what if this is 0? Then what's the output? Is it still 5 or 4? Please, it's 2, right? Okay. It won't be max, right? It will be result plus because result plus and then all of those things. And again, over here it will be 1. Then it will be right, right? Yeah, it's 1 and then now it's right. Now it will be right. Because wahan pe it will be, okay, now it's 12. I think so. This will be, again, let's say this is 0, right? Then my last one I'll say result return. I think so return result plus length of grid, oh my bad, grid multiplied by length of grid of uh, 0, because it's very trivial and simple that that will happen at some point of a time. Yeah, so let's run this stuff, and this should be correct right now, or is it not? Where do I need to close? Okay, one more thing will come in. Yeah, run the code. Yeah, that's correct. Use the example test cases and run this. Should be correct if I'm not wrong. Correct. Let's submit this. I think so. There will be a problem that I did not do 10 to the power 9 modulo 7, right? 10 to the power 9 modulo 7, I never did. Okay. Okay, so we have TLE, but again, that will come up surely because we have to do this 10 to the power 9 this thing, right? So I'll just copy that. I'll do a mod of this. Makes sense. This is going to be simply this. In Python, it's quite easier to declare this. So it is as it is. It is as it is. Uh, every single time I do this, I say that okay, count paths, count paths, mod this value. Then here as well, I'll say mod this value. Once done, I can probably go for that optimization. So that would look something like that. That okay, dp is empty, and then I'll probably pass in dp here, dp, and no, it should not be passed in here. Should be here in complete function, right? dp, and then that same thing will come up here as well. Beautiful. So here itself again, I'll say that okay, now what's my current cell? That's probably row comma column, and I'll see that okay, if my probably current cell in dp, then I return that value back. Done. So this is basically I'm checking if the current cell is visited or not. Visited or not. But if it's not visited, then end of the day I have to memorize the value. So I can simply say memorize the value. That would look something like this. So dp of the current cell is gonna be the max or count paths. That should be pretty much it. Submit this. Done. So this was again very much similar to the previous one which I've done, but in this case it was more like key. I have to count the number of ways, the number of paths there. But in that case, I just had to find the longest increasing path. That's it. So in that case, we had something like result is a maximum of result and this compute. But here I just simply need to add because it's count that thing, right? Count part comes in. Also count paths is I think so same variable name, which is not right to write this. So let's just say count path, and then all of those things. This will be count path, and then this will be count path. It should not be same the name. Yeah. It looks pretty much good. We have all paths from source to target. We'll see this later on. Let's move on to these problems again. Okay, so we just did distinct subsequence has been done earlier. We did longest increasing path we have done. Hmm, hmm. Okay, what is it saying? This solution. So split array largest sum data. This looks good. Let's see. I'll take a quick break and then come back. Yeah. So I've been talking to John Barnes. Thank you, man. Your live streams are just great. Found out about you recently. Thanks. It means a lot. Okay. We have this question: split array largest sum. Also, yeah. Thanks, man. I'll also improve on the audio quality. So probably I'll put on these headphones. I think so. You can see this headphones and all of those things. So I'll do that later on. For now, but yeah, I'm trying my best. If you don't mind, we will be able to connect over LinkedIn, right? So you can get my LinkedIn ID, I think so, through about. So if you go to my channel, in the about section, you will be getting my LinkedIn ID. So we can connect there and we can have a talk. We can also solve problems during weekends if you don't mind. Okay, I'll continue. So split array largest sum, right? So given an array nums which consists of non-negative integers and an integer m. So given an array nums which consists of non-negative integers and an integer m, you can split the array into m non-empty contiguous subarrays. Great. Write an algorithm to minimize the largest sum among these m subarrays. Is this a binary search kind of a thing? Yeah, binary search. Okay. So you can split the array into m non-empty continuous subarrays, by the way, and write an algorithm to minimize the largest sum among these m subarrays. Okay. So in this case, it's like two subarrays have to divide it, right? So it could be something like 7 to 5 and then 10 8, right? And then if this is 7 to 5, so m is the value, right? So there are four ways to split the nums. The best way is to split into 7 to 5, and this. Yeah, thanks, John. So where the largest sum among the two numbers is only 18, okay, and I have to minimize that value, right? Other could be 7, 2 is 9, but the largest would be 23, right? That's the problem, and I get the point. So when m is 2, this is the thing, then I think so. 5, 4, 9, and then 1, 2, 3 is one split. M is 3, I guess answer is 4 because 1, 4, 4. By default, I have to split it. Correct. So m is going to be the minimum of 50 and num's length. So num's length is if it's 30, then m is going to be less than 30. But it's even if it's 1000, it will be not more than that. So it will be 50 itself. But I have to forcefully split it, right? It cannot be empty, non-empty, right? Continuous subarrays. Correct. So the idea here could be key. Let's say the array looks something like this. Um, 5, 6, 7, and okay, so let's say the array elements are A, B, C, D, E, right? So let's say M value is 2. So I can start a split here, and here my split value will be, I guess, M is 2. When I split this, I come here, M value is 1. So I cannot split it further, right? So when M value is 1, I cannot split it further. So there could be one split where A, B, C, D is there. There could be one split wherein, let's say, this is the split, this is the split, and this is the split. Okay, when M is 3, I know for a fact split possibilities go like this. And then it will go here, go here, go here, that will go here, and that's the end of the day. Okay, it's a lot of writings, clear canvas, this thing. So what we can do here is, I can simply start an index here itself, and then so it would look something like this: for index in range, whatever my array's length is, let's say n, this is of length n. I will say that okay, let's do a split here. One more thing could be, let's not do a split here. That's it. Two things, right? let's do a split here and let's not do a split here, right? Two things. So if I split here, what will happen? If I split here, what will happen? So there could be something like running sum, right? Running sum. So if I split here, then I guess hmm, that running sum is the only requirement, right? I don't even need to worry about anything else. So that running sum comes to the end, and in that case, I can say out of all the running sums, what's the maximum? That's it. So I could store that in a set, right? So when I split here, whatever the running sum was, I'll put that into set, correct? And then hmm, I'll call a function at something like this. Let's do a split here. I'll put that into a set, and then my running sums resets to 0, and then I also say key. Let's call a function f at index plus 1, and then running sum is 0. That's it. If I don't do a split here, then I'll add it to the running sum. So that will be a of idx. I'll move to the idx plus 1. That's it. Two things which are being done here. Yes, and end of the day, I think so. I'll have to maintain something like an array like this, and then here itself, I'll say key. What's my maximum running sum? So I could pass here. Yeah, once this is passed, I could say here key from max something like this, right? Max, which is initially 0. So I could update here something like max of my previous max, which was called in the function, and then my running sum. Yeah, so there's one idea here that let's just like create the skeleton of the entire thing. So let's say define uh, let's say compute, right? I have to compute what? Split the largest, add in the largest sum, right? So I have to minimize. So let's say the function m is solve, and then I think so I have to pass in the index initially, and then I need to pass in yeah, the index initially, and then the nums itself. I think so these are the two things I need to pass, right? I need to also pass in the running sum and the max. So base case, let's look at it later on. First form the logic here. So that would look something like this. For I in range um, idx till length of nums. Beautiful. Also there is one parameter called m, right? So that's idx nums, running sum, max so far, and then so here itself I'll say that okay, for I in range idx comma length of nums. Okay, yeah, base case I can think of right now. Yeah, I'm able to figure out, but we'll write that later on. So this could be that okay. Let's do a split at I, or I won't do a split at I, right? So let's do a split at I, or let's not do a split at I. Beautiful. So this will be let's not do a split at I. Done. If I split it, so I'm saying that okay, let's do a split, and then we have not So in the case of split, I think so. Let's say if I don't split, what will happen? What will happen? I'll call the solve function. It will be at index plus one. Great. Nums will be as it is. So by running sum, I'll add in this value, which is running sum plus um, nums of I, and then max. My bad, max. So far will be as it is. So it'll be m minus one. Yes, m minus one. This is for not split. But if I split it, I think so. I need to do something like this. That okay, let's call a function solve. This will be at definitely idx plus 1. Nums will be as it is, correct? And running sum will be reset to 0 if I'm not wrong. But here this will be maximum of max so far and running sum plus nums of I, because I'm taking in this number at this current index and then I'm saying okay split it and then go forward, so that will be probably m minus 1 if I'm not mistaken. That's the split value. Beautiful. Makes sense. Makes a lot of sense. Like literally a lot of sense. If I split it, this will happen, and then if I don't split it, this is something which will happen. If I'm not splitting it, m will be as it is, right? Why am I writing m minus one? What am I doing? So I think so. End of the day, I have to return. Let's say if I split it, then the max so far would have been something, and that would have been returned. But let's say if I don't split it, then hmm, by the way, when can I do a split? If m is greater than 1. If m is 1, it means I can't. If m is 1, I cannot. And not split is absolutely fine. Um, Base case could be that if my m is equivalent to 1, in that case, it could be that, okay, it's split here, splits here, then it's 1. So I cannot return stuff randomly, right? I have to go with not split option and then ho jayega. So if let's say my index reaches the very last position, which is the top nums, in that case I think so I simply need to in this case I think so also check m is equal to 1, which means hey, it's the end of the day, so return max so far, because that's something I'm interested in. And I think so I have to return maximum of max so far and whatever my running sum would be at that point, else I'll return back 0. That's something I'm looking at. And end of the day I need to return the maximum of split, and then what if I don't split, so that would be not split. And again this could be written as this value, so max value is 0, max value is maximum of split and then not split, and then Here I'll return max value. Let's run this stuff and see if it's working. Acha. It's really wrong. Output is 40 and then they expected 18, right? So I think so this could be minimum if I'm not wrong. कि वहां से max निकालना है and then ये कर रहे हैं तो it could be minimum, not sure. But then that's wrong as well. Mm, mm, I think what's about. So this will be I plus 1, right? Oh my god. This is also okay. I think this will be max itself, I guess. Let's see. Let's see. Let's see. That's 18. So we have to have, let's say, many. But no, that will never give me the answer. No. Okay, why was it 8? First of all, I have this running sum with me, right? Why was it 8, by the way? I'm writing something like this, right? Max. Hmm. So when it's considering 8, why it is not considering the remaining values, which is like quite big enough. In this case, it's 7 to 510. Some problem in the algorithm. Oh, so could be this thing. Server 0. No, this is not how it should be. This is nums of I. Yeah, it's still the same thing, right? यहाँ से अगर split कर रहे हैं, so running sum would be that, and then इसमें nums of I will be added. Makes sense. This will never be reached. I see. So this will be minus 1, and if that's then. Hmm. That will be reached at some point of a time. कि उतना आगे आएगा सो पाई डी एक्स होगा क्योंकि उतना दूर तक जा ही नहीं रहा। अच्छा जीरो अभी भी दे रहा है बट हाँ मेक सेंस की I have to go in that direction. Or I could write like this. If m is 1, then simply return uh, sum of nums from idx till the very end. Also, if idx reaches length of nums, I return back 0. Or else I'll do a little vice versa thing here. I'll just put this above. Yeah, I'll put this above and then see how this goes on. Still wrong. M sub arrays, right? अच्छा, so hmm, let's take this and try to see what's happening. कहाँ पे गलती हो रहा होगा? Correct. This is this. Get rid of that. Nums and then that thing. So I'll provide it real quick. So last, it's giving me 0, right? Okay. Why? Let's see. This is this. अच्छा, when I'm at index 0, right? And I'm saying कि okay, let's do a split. तो क्या हो रहा है वहाँ पे? Split हो रहा है. But I'm also saying कि I plus 1 में मैं जा रहा हूँ. And then running sum is 0. Max is max so far. And running sum plus nums of I, right? तो max so far definitely update हो गया है. In the next iteration, what's going to happen is कि since m is not greater than 1, I'm not splitting it, right? So solve I plus 1, I have to go. Definitely nums will be as it is. Running sum में nums of I add हो गया, right? Max so far will be as it is. M will be as it is. And when this is being called, I'm also saying कि okay, let's just do this stuff. यहाँ पे मैंने कहीं गलती किया है क्या? यहाँ तो सही दिख रहा है। सो एटलीस्ट मैक्स वैल्यू 23 तो देगा, वो भी नहीं दे रहा है। हम्म। मैक्स वैल्यू 18 है। व्हाट्स हैपनिंग देन? मैक्स वैल्यू 18 आ गया देन। Okay, so that thing is getting hampered here, right? I believe so. That 23 was not applicable as M was 2, and max value was 18, and is still 2. Okay, I'll do this tomorrow. I don't have any space left in me. Close this and then I'll close this.